sharding and replication allow you to do is basically split the data that you have over multiple machines, and also split the type of requests that are incoming over multiple machines. Okay? So the easiest type of sharding we can do, and it's a really big win for us, and probably the easiest to implement, is to just separate services that are not related onto different machines. Okay, just completely separate from each other. So we have a storage service, which is like a key value store. So basically you're giving a file ID, and we store global data associated with that. Okay? Just like, so all your requests will come in will always have a file ID. We have to either retrieve or write a blob into that section. Right? Our matchmaking service then is completely different, because this allows us to run ad hoc queries, where a game request can come in from a client and say, I would like all of the games in Europe that are playing on this particular game type, that have this number of players, and that the players have this experience level. So we have to kind of run these ad hoc queries. That has nothing got to do with storage. So one of the big wins for us straight away is to just separate those out. So when a service comes in, you basically look at the service, and we're immediately able to direct that service request to a specific cluster of machines. Okay? The next big win then comes from sharding. And what sharding means is that you take your data and distribute it over multiple databases. So the example here I use is storage. So what we do is, for sharding to work, we need what's called a shard key. And this shard key is basically a value that is always passed up to the request that identifies that piece of data. And we use that shard key to identify which shard our data should go on. So what will happen is, you can see our table on the left. Every time a file ID comes in, we just calculate the modulus of that file ID by